Hi, this is Ashwini from Cheta. Today, we will talk about a connection between geometry and algebra that often comes up in Math Olympiad problems. At the end of this video, I will ask a question that will depend on the entire discussion in this video, and you can give a response in the comment. So here is the setup. We have a triangle ABC like this, and we have a circle. For the moment, suppose this is a unit circle, which means the radius of it is 1, and the center of the unit circle is O, and all of these points A, B, C are on the circle. Okay. Now, I want to draw an angle bisector of angle A that hits this arc BC at the point M. Okay. So this is an angle bisector. These two angles are equal. It's given that the length of the arc BM is x centimeter. That is given. Can you tell me what is the length of the arc MC? What is MC? So the next part of the video will answer this question and also connect with the notion of complex numbers, and then ask a final follow-up question at the very end of the video. Okay. So now this is a very simple, this part is extremely simple. The length of the arc MC is also x centimeter. Now why is that? Well, let's look at it like this. If you connect OB and OM and OC, see this particular angle here is half of angle A. So angle at the center is twice the angle at the circumference. This is a very well-known property of circles. So this angle right here is twice of this particular angle. They are subtended by the same arc. So this angle right here is twice this angle. So this one is angle A. And similarly, you can also see that MC subtends MOC at the center and MAC at the circumference. So this is A by 2, which means this one is also angle A. Now, we know that arc over radius is angle. Angle is equal to arc over radius. So BM by radius is the angle A, and CM over radius is also the angle A. When I write BM, I'm actually writing the arc length. When I write CM, I'm actually writing the arc length. So in fact, we can say that BM and CM, both of these arc lengths are actually equal. We arrive at a very interesting conclusion that if we draw the angle bisector, it splits this arc into two equal parts. Okay, that's great. Now, let's go to the next section where we connect it with complex numbers. So, this particular complex number, well, it's a position, so you can actually give a complex number coordinate to it. So, this is A, this is B, this is C, suppose. So, let's use the small letters to denote the complex coordinate of it. So, I mean, if you want, you can write it as A1 plus I A2, B1 plus I B2, and C1 plus I C2, and so on. Okay. So, but I mean, it's not that important. you can just simply write it as small a. One of the properties of this complex coordinate small a is that its distance from the origin is 1 because it's a unit radius circle. So you take the distance of that point from the origin, and that would always be the length of the radius, which is 1 in this case. So absolute value of a, absolute value of b, absolute value of c, all of them is 1. And if you want, you can obviously write absolute value of a as square root of a1 square plus a2 square and so on. That's fine. It's just a distance formula. Now the question really is this, that what is the complex coordinate of m? What is the complex coordinate of m? We already have this information that m is the midpoint of this particular arc. Also, the distance of m from the origin is 1. And we know the complex coordinates of a, b, and c, which are small b and small c. So in terms of small b and small c, you can probably, theoretically, you should be able to find out the complex coordinate of the midpoint of BC arc. Okay, so that's the challenge that I want to give you. And that's the first thing. You find the midpoint m of the arc, given this one is b, this one is c. And then with that, can you find out the complex coordinates of the incenter I? So these are the two questions. Try them, put it in the comment, and I will look into it. And we can have some more fun with complex numbers, geometry, and Math Olympiad problems in the upcoming videos. All right. Thank you and all the best.